Alright, you're welcome to the part 2 of this video, unit and measurement. Please, if you've not watched my part 1, if you've not watched the part 1, please go and watch it under unit and measurement. So we'll start with question number 9. So question number 9, they said the dimension of force is dash. A, ml2 t bar 2. B, ml2 t bar 3. C, ml t bar 2. D, ml bar 1 t bar 2. Now listen. Now this type of question, what do? You just get angry and leave the hall. First of all, you ask yourself, what is the formula for force? The formula for force is mass times acceleration. Mass times acceleration. That is the formula for force, which is F is equals to ma. So definitely you know that the dimension for mass is m, right? And you know that the dimension for acceleration is lt bar 2. lt bar 2. So for us to calculate for the dimension of force, I will now have it as force will now be any place I see mass, I'll put m. Any place I see acceleration, I'll put it as lt bar 2. So I'll now have it as m L T bar 2. So do we have anything like MLT bar 2 in the option? Option A, no. Option B, no. Option C, yes. So the dimension of force is option C, which is the correct answer. MLT bar 2. Let's go to question number 10. Question number 10. Question number 10. It said all the underlisted units except one are all derived units. So I want to look at the one that is not a derived unit among all of them. You get? Now Joule, first of all, let's start with option A. Joule is actually the unit of what? Energy. Energy is a derived unit, so it cannot be the answer. Option B, Newton is also a unit of force. So, and force is a derived unit as well. Option C, candela. Candela is a unit of what we call luminous intensity. You get? So, and luminous intensity is a fundamental unit. Radian per second is a derived unit. So the one that is not a derived unit is candela, which is fundamental unit. So the correct option is option C. Now, number 11, the dimension of power is dash. Option A, ml2 t bar 3. Option B, ml t bar 3. Option C, m square lt bar 2. Option D, ml2 t2. How do we solve it? First of all, if you're solving any equation under dimension, the first thing you need to do is to know the formula first. What is the formula of the physical quantity given? The physical quantity given is power, B. So what's the formula for power? You know that power is work done over time. Work done over time. What is work done? Work is force times distance over time. So do we know the dimension of force? Yes. What is the dimension of force? The dimension of force is ml/t bar 2. This one is for force. Then times, what is the dimension for distance? L. All over, what is the dimension for time? I have it as t. So what will happen is that I will now have that the dimension of power will now be m, to bring it down, L times L is L squared. I'll have it as L squared. You get? So I will now have t bar 2. Then this t going up will be times t bar 1. So I will now have the dimension of power will now be m L squared. Now obey the law of indices. Take one of the base and add the powers. So minus 2 plus minus 1. Remember that plus minus is minus. So this thing is said as minus 2 minus 1. What is minus 2 minus 1? Minus 3. You have it as t raised to power 3. So the dimension of power is ml squared t bar 3. Do we have anything like ml squared t bar 3 in the option? Yes, which is option A. ml squared t bar 3. Option A. So, question number 12 is which of the following or which of these is the dimension of viscosity? Which of these is the dimension of viscosity? Viscosity. So the question is, what is the formula for viscosity? Viscosity. What is the formula for viscosity? Viscosity is force all over area times velocity gradient. Times velocity gradient. That is the formula. Do we know the dimension of force? Of course, dimension of force is ml t bar 2, right? Do we know the dimension for area? The dimension for area is L squared. Now, what is the dimension of viscosity and velocity gradient? The dimension of velocity gradient. Velocity gradient. So what does velocity gradient means? It just means velocity over length over distance. So if it is velocity over distance, that means I will have a velocity over distance. And what's the dimension for velocity? L t bar 1 all over. What's the dimension for length? L. This L will cancel this L. So what is the dimension for velocity gradient? I'll have it as t bar 1. Now that I've known the dimension of force, I've known the dimension of area, I've known the dimension of velocity gradient, I will now put it in viscosity. So how do you sum it up now? So I will now have that the dimension for viscosity will now be, what is the dimension of force? M L t bar 2 all over. What's the dimension for area? L squared times what will be the dimension for velocity gradient? T bar 1. You get? So 1L, we cancel 1L here. How many L will remain? 1, right? Then this moving up, which we turn to plus, I will now have it that the viscosity will now be M. Remember that we have 1L. Okay, let me analyze it. M then times T bar 2, right? Times T plus 1. You get? All over, you have 1L here. And you know that 1L also going up will be minus 1. I will now have the velocity gradient will now be M L bar 1 minus 2 plus 1. What is minus 2 plus 1? That's minus 1. T bar 1. So do we have anything like this in the option? M L bar 1 T bar 1. Option A says M L bar 1 T bar 2. No. Option B, M L bar 1 T bar 1. So the correct answer is option B. Number 13. Derived units include. What is a derived unit? It includes option A, mass kilogram seconds, B, meter Kelvin candela, C, meter kilogram mole, D, density, velocity, pressure. I've told you what fundamental quantities are. If you can be able to know what fundamental quantities are, then it means that you know what derived quantity is. So first of all, what are fundamental quantities? I told you that you use these acronyms: STOR, CMT, or CMT. This T stands for time. A is amount of substance. L is length. This second L is luminous intensity. C is current. M is mass. and T is temperature. Now, what is the unit of time? The unit of time is in seconds. What is the unit of amount of substance? Mole. What is the unit of length? Meter. What is the unit of luminous intensity? Candela. What is the unit of current? Ampere. What is the unit of mass? Kilogram. And what is the unit of temperature? Kelvin. So let's answer that question. So derived unit include, that means anyone that is not among this is a derived unit. Mass, option A, mass, kilogram, seconds. Mass is a fundamental unit, so mass cannot be a derived unit, including the kilogram and the seconds. Option B, meter, Kelvin, and candela. Meter is a fundamental unit. Kelvin is a fundamental unit. Candela is a fundamental unit. Option C, meter, kilogram, and mole. Meter is a fundamental unit. Kilogram is a fundamental unit. Mole is a fundamental unit. Option D, density, velocity, and pressure. Those options are derived units or derived quantities. So the correct answer here is option D. Number 14. It said, which of the following is a fundamental unit? Is a fundamental unit. Option A, they say watt. Option B, Newton. Option C, Kelvin. Option D, joules. Now look at the options. Now, watt is a unit of power, and power is a derived unit. Newton is a unit of force, and force is a derived unit. Kelvin is a unit of temperature and is a fundamental unit. If you watch, this is temperature. What is the unit here? Kelvin. Joule is a unit of energy and is a derived unit. So the one that is a fundamental unit is option C. Option C. So number 15, the coefficient of viscosity, the unit of coefficient of viscosity is dash. We want to know the unit. We've calculated the viscosity before. If we calculated viscosity before, what would be the unit? Now, how do we get the unit? Okay, when we calculated for viscosity, we said that the option is option B. That means if you come to viscosity, coefficient of viscosity, what is the dimension? M, L bar 1, T bar 1. You get? So we want to get the unit of this viscosity, where M is mass, L is length, T is time. What is the SI unit for mass? Kilogram. What is the SI unit for length? Meter. Per 1, because there is per 1 here. What is the unit of time? Seconds. Per 1, because there is per 1 here. So do we have anything like? All right, question number 16. They said the SI unit of angular momentum is dash. Option A, kilogram meter per second. Option B, kilogram meter square per second square. Option C, kilogram meter square per second. Option D, kilogram meter square rad or radian per second. Anyone. So how do you solve this? You need to know what is angular momentum. This angular momentum is also called moment. Moment of momentum. Moment of momentum. And what is the formula? Angular momentum is equal to linear momentum. Linear momentum, that is momentum times distance. Momentum times distance is called angular momentum. So what is momentum? Momentum is represented as P, right? While distance is represented as D. So I will now have, what is the formula for momentum? Mass times velocity, then times it by distance, right? What will be the dimension for mass? Dimension for mass is M. Dimension for velocity is L T bar 1. Then dimension for distance is L. So I will now have it that M L times L is L square, then T by 1. We are not looking for dimension, we are looking for units. So how do you get the unit? The unit of mass here is kilogram. The unit of length here is meter square, while the unit of time here is seconds per seconds. So option A, we have kilogram meter per seconds. No. Option B, we have kilogram meter square per second square. No. Option C, we have kilogram meter square per seconds. Yes, the correct answer is option C. So see you in my next video. Thank you. God bless you.